Okay, so again, picking back up here, I believe at the point we were at, was there like 7 of the first 14 that we were able to do on calculator with this one? Yeah, they're on. Yep. Weren't we like 7 of the first 14 that we were able to do just straightforward calculator? Can you check back at your tally for me? Or maybe it was only 5. I can't quite remember. Maybe it was more like 5. Yeah, 6 and 7, 4, 2. Yeah, maybe it was only like 5, I guess, out of that one. Okay, but again, what was the little mnemonic we had for the product of the roots, the sum and the product of the roots on number 14? Good. The sum bad apples produce canned applesauce told us that the sum of the roots was negative b over a, and what we needed here, the product of the roots, was c over a. So we had to get this equal to 0 first. So minus 5 equals 0. So our c value was negative 5. Our a value was 2, so we got choice 4 with that. Okay, moving on into number 15. Now 15, is 15 really an Algebra 2 and trig question? Nope, you would have seen this one right off of your geometry Regents exam as well. One of the topics that carry over from geometry is the center radius equation of the circle. So we have a circle that has this as any point on the outside of the circle, but we're centered here at HK, which is 3, negative 4. So which ones are automatically crossed off for us on this one? 1 and 2. Why are 1 and 2 automatically out? They're not using the center, are they? Okay. This right here, we need x minus h squared plus y minus k squared equals an r squared. Well, h and k represent the coordinates of the what? What do the h and the k represent? They represent the center, right? They represent the center. Well, my center is 3, negative 4, not this one. In solutions number 1 and 2, they're using the point that's on the circle, not the center of the circle. Okay? So we definitely want the minus 3 and the plus 4. And now we just got to determine what our radius is. Well, how are we going to determine our radius? Well, quite simply, we know it goes through the point 3, negative 4. That's the center at 3, negative 4. And then some point on the circle is over at 6, 5. So over at 6 and up at 5. So if this is the center of the circle and that's a point on the circle, then if we connected those 2 points up, we would have the what of the circle? The radius of the circle. So what we need to do is now is find that length right there. Well, we could do another thing from geometry and use the distance formula, but I think the distance formula is more complicated than it needs to be. Just connect up your center and that point on the circle with a right triangle and use the what to find the distance there? Pythagorean theorem, right? Okay, how many units is it from 3 to 6? 3 units, right? How many units is it from negative 4 up to 5? 9 units. So what's 3 squared? 3 squared is 9. What's 9 squared? 81. Well, 81 and 9 is equal to what? 90. So my radius squared, which is exactly what we need, is equal to 90. So are we choice 3 or choice 4? We're choice 4. X minus 3 squared plus y plus 4 squared equals my radius squared, which is equal to 90. We're choice 4 with that one right there. Okay. Folks, it would take a while, but could I solve this right here for y and graph that equation and verify that it goes through that point? Absolutely, I could. I absolutely could. I could also go through every one of these and put the 6 in for the x and the 5 in for the y and find out which equation works as well. It's probably the easiest way to do this one. And if I plug in the 6 right here and the 5 right there, we're going to get that equal to 90, which is exactly what we want. Okay. All right, 15. And again, 15, there again, they're throwing a question on that's really a geometry question, not an algebra 2 trig question. Something we got to recall from that as well. Any questions on the center radius form of the circle? Would have been much better if they would have given us the standard equation of the circle and asked us to complete the square to get it into center radius form. Okay. Our PERT formula, we've got an exponential function here. Our amount is equal to our principal times E. What is E? We call E natural base. E is our natural base, right? And we've got 2 places for it on our calculator that we can find it. So we've got our formula here. They want to know which equation could be used to determine the value of an account with an initial investment of $18,000. What variable is that? That's our P. That's our principal. At an interest rate of 1.25%, what do we have to do with the percentages, though? To a decimal. So what is our R value going to be? 0.0125. Good. And we want 24. Now careful here, folks. This is a reading question again. T is the time in years. Well, they've given me months. 24 months is 2 years. 2 years. Okay. But do you notice here they've got the 24 and here they've got the 24 as well? Those have to get crossed out automatically. And why does number 1 have to get crossed out automatically as well? They did not change the percent to a decimal. Okay, so we want this one here with the 18,000 times e to the 0.0125 times 2 years. It's 2 years. Okay, and again, if you didn't read that one carefully, they're basically trying to trick you on your reading. Okay. Completely unfair. Completely unfair. I mean, is that testing your knowledge about using that formula at all? No, absolutely not. But if you didn't take your time and read that, we're out 2 points. Okay. 17, are we right back to the calculator? Absolutely. They're asking me to solve an equation. They're giving me possible answers. We want to test which one of these answers will work. Okay? So, what is the first value that we are going to store as x? 2. Yep, choice number 1 starts off with 2. So we're going to take 2 and store it as x. And now we're going to type in the equation. What do we have to be very careful of, though, here in this equation? The parentheses with the fraction. How am I going to enter in this 30 divided by x squared minus 9? Open, open. Open the whole fraction. Open the top. And what is the top? 30. Close the top. Divide it by. Open the bottom. What's my bottom? X squared minus 9. Close the bottom. Close the whole fraction. And what are we doing with this 30 over x squared minus 9? We're going to add it to 1. And set it equal to, where do we get the equal sign from? Second math, right? Second math is our equal sign. And we're going to set this equal to, now how am I going to type in the fraction of 5 over x minus 3? The same thing. Open, open, 5. Close, divide, open, x minus 3, close, close. Okay, so is 2 a solution? Yes, it is. 2 is a solution, so what's automatically crossed off then? 4 is out, because 4 means what? There's no solution. Well, definitely 2 works. And 3 is out as well. 3 might be a solution, but is it the only solution? No, because 2 is a solution as well. So 3 and 4 are out of the question. 2 does work, but now we need to check and see if what else also works. 3. So now we're going to take 3 and store it as x. We don't have to type in the equation again. We're just going to go ahead and hit second enter. So there's my equation again. And does 3 work? Why does 3 not work? 3 minus 3 gives me a 0 in the bottom, doesn't it? So 3 can't work. My only choice is option number 2, right? Option number 2. Okay? Let's talk about doing this one by hand, though. What do we not like in this equation? We don't like the fractions, do we? We don't like the fractions. Well, fractions just simply mean what operation? Division, right? And how do we undo division? With multiplication. Okay? So how are we going to undo this x minus 3? By multiplication by x minus 3. Well, instead of doing individually each fraction, well, let's look at this one and realize that x squared minus 9 is really what? X plus and x minus 3. So what is the common denominator for all of my fractions? Yep, we're going to multiply everything by a factor of x minus 3 and a factor of x plus 3. And see what happens. So what's going to happen when I distribute my first term to the common denominator? Yeah, both the x plus 3 and the x minus 3's cancel out, and I'm just going to be left with the what? The 30. 30 plus. Is anything going to cancel out when I distribute the 1? No, because the 1 doesn't have a denominator, so it's going to be x minus 3 and x plus 3. But what is x minus 3 times x plus 3? The x squared minus 9. So plus x squared minus 9. What's going to cancel out for me when I distribute the 5 over x minus 3 to it? The x minus 3's, but I'm going to be left with 5 times of x plus 3. And what is 5 times of x plus 3? Five x plus 15. So now is that a little more friendly of an equation for us? Yeah, all of our fractions are gone. This is what kind of an equation? Quadratic, which we're going to set equal to what? 0. Am I going to move everything to the left or everything to the right? Everything to the left. We want to keep that x squared positive, don't we? So x squared. What will come over after the x squared? A negative 5x. What's 30 minus 9? 21. And how do I bring that 15 over? We subtract it. So what's 21 minus 15? Positive 6 equals 0. What are the 3 ways we have to solve a quadratic equation? Quickest and easiest, if it will work, is factoring. Process of completing the square. Or we've also got the quadratic formula as well. Quadratic formula. This one we can factor. My signs are going to be same. They are both going to be negative. So we're going to have an x minus and an x minus. There are 2 sets of factors for 6. We've got 1 and 6, which will subtract to give me 5. And we've got 2 and 3, which will add to give me 5. Which one do I want? The one that subtracts to 5 or adds to 5? We need the one that adds to 5. So we want the 2 and the 3. Negative 2 and negative 3 is negative 5, but when we multiply them, we get positive 6. Okay? So folks, if x minus 2 is a factor, then what is my root? X equals positive 2, and x equals positive 3. So we're thinking, all right, we're going to circle up number 1. No, because what is the one thing I've harped on you about all year when you solve an equation? You've got to check it. And when we check it, when x is 3, 3 minus 3 gives me 0. It can't be the 3, so then it's got to be choice number 2. Got to be choice number 2. always going to see a fractional equation on the Regents exam. It'll either be in part 1 or part 2. Part 1 where you can do it in multiple choice, or part 2 where we got to do it shorthand. But again, any questions on how we did this in the calculator when it shows up in part 1? Okay, just take the values they've given you, store them, find out which ones work. Okay? To 18. All right, 18 is just a very basic question again. What is the approximate range of the graph? Which values are the range? The y values are the range. So as I look on my graph, it looks like probably right around here is my lowest value. Okay. Right around there is my lowest value, and right up around here is my highest value. So it looks like on the y-axis we go from around where to where? I guess I should ask first off, which two are eliminated right off the bat? Y1 and 2. These values are domain. X values are domain. We want y values. Okay? So is my lower y value lower than 1 or greater than 1? With the 0.97 or the 1.27? It's a little bit lower than 1. We want the 0.97 up to the 2.38. It starts right here at around 1.27, but is that the lowest value? No, the lowest value comes down to around here, around roughly 0.97. So domain is x values, range is y values. Now what would the domain be on this one if they asked the domain? Where do my x values start and where do they end? 1997 to 2007 would be the domain. Okay, but the range is specifically the y values. Questions, domain range? Is this a function? Is this graph a function? Yes, what does it pass? Passes the vertical line test, right? That would be a function. Another good question, a composition. What is f parentheses g of x? Which one has to be done first? Why the g of x? It's inside of the parentheses, right? So we've got to do g of x first. And g of x was told to me to be x plus 5. And then what follows g of x? F of x follows g of x. These are those compositions that you did in geometry. Okay. And f of x was told to be 2x squared minus 3x plus 1. And now, is there a specific number that they want me to run in through this composition? Or do they just want me to use the general x? They're asking me to use just the very specific x value. So I'm going to plug in x. And what happens when I plug x into g of x? What is outputted for me? X plus 5, right? X plus 5. And now, what am I going to do with the x plus 5? I'm going to plug it in up here. So wherever there's an x, I have to replace it with, so f of x plus 5 is equal to 2 parentheses x plus 5 squared minus 3 parentheses x plus 5 plus 1. So that's the algebra 2 of this. But in order to get the question right, we've got to do the algebra 1 simplification. Do I multiply or do I square first? I've got to square first. So what is x plus 5 times x plus 5? Good. X squared plus 10x plus 25. Okay, go ahead and distribute the 2 now. What do you get? 2x squared plus 20x plus 50. Okay. Distribute the 3 for me, please. Minus 3x minus 15 plus 1. So altogether, what do we have for x squared? 2x squared. Does that eliminate any of my possibilities? No. What do we have all together for x? Does that eliminate some of my possibilities? Which ones are out now? 3 and 4 are gone. 3 and 4 are gone. So it's between 1 and 2. Okay, so what's 50 minus 15? 35, and one more? Choice number 1. Choice number 1. Now, folks, seeing that this is a multiple choice question, could I let x be any number that I wanted? Yes, I could let x be any number that I wanted. Say I wanted it to be 11. So if I run 11 through, what's 11 plus 5? 16. And then could I run 16 through over here and get a numeric value out of it? And then just type these into the calculator and find out which one gives me that same numeric value? Would that be a great way to do this one? Absolutely would. You wouldn't have to do any of the work. I'm going to plug in whatever number I want for x. I still need to know what that means. I mean, I can't do this completely on the calculator with knowing nothing. I've got to understand the composition, but plugging a number in for x would make the composition a lot easier. And then I could plug in and find out which one gives me that exact same numeric value. Okay? Any questions on the composition? Can you tell me what the other notation was that meant the exact same thing as that right there? The little circle. Now, is it f circle g of x or g circle f? It would still be f circle g of x. And how do you read this? Follows g. F follows g. Just like it does over here. F follows g. So I've got to do g first because it's inside of the parentheses. Okay? The Regents will use both notations. We've got to be familiar with both. Okay? All right, with 19. 20 is a recent one that we've just seen. A jogger ran 1/3 of a mile on day 1, 2/3 of a mile on day 2, 1 1/3 miles on day 3, 2 2/3 on 4, and this pattern continued for 3 more days. Okay? So we started with 1/3, then we went to 2/3. Folks, one full is how many thirds? 3/3, right? So 1 1/3 is really how many thirds? 4/3. So 4/3. And then we go to 2 2/3. Well, how many thirds is 2 whole? 6/3. 6 and 2 more is 8/3 on the 4th day. So here's my first term, my second term, my third term, my 4th term. And they said it continued for 3 more days, so we want the 5th, 6th, and 7th. Which expression represents the total distance the jogger ran? Okay. Notice what is consistent about every single one of these. All 4 of my choices, what's consistent? From 1 to 7. Okay, so is there anything we can eliminate from 1 to 7? No, this is day 1 to day 7, and then we've got to figure out how many miles we got. Now, this is just a guess and check problem here, folks. I need to plug in 1. And when I plug in 1, I need to get what? When I plug in 2, I need to get 2/3. When I plug in 3, I need to get 4/3. When I plug in 4, I need to get 8/3. So I just need to do trial and error here and find out which one's going to give me what I need. Okay? So let's look at this one here. What's 1 minus 1? 0. And anything to the 0 power is 1. 1 times 1/3? So is that one going to work for 1? Yes. How about 2? What's 2 minus 1? 1. 2 to the first power is 2. And what's 2 times 1/3? 2/3. So it's working, right? 3. What's 3 minus 1? 2. 2 squared is 4. 4 times 1/3? 4/3. 4. What's 4 minus 1? 3. And 2 to the third power is 8. 8 times 1/3 is? It's looking like we got what? It's looking like we've got choice number 1 here. Okay, none of the others are going to work like this. Look at number 2. When I replace it with 1, what's 2 to the first? 2. And 2 times 1/3 would be, well, we needed it to start at, so it's not that one. What's 1 minus 1? 0. And anything to the 0 power is 1. And then 2 times 1 is 2, not 1/3. Okay. And back to the first power again. 1/3 to the first power is going to be 1/3. And then 2 times 1/3 is 2/3, not 1/3. Not 1/3. Okay? Let me show you another way that's not guess and check and trial and error on this one. I need to recognize that this is what kind of a sequence? Are we adding and subtracting to get from term to term, or are we multiplying? We're multiplying. This is a geometric sequence. And this geometric sequence has a common ratio equal to what? What am I multiplying by to get from one to the next? I'm multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. My common ratio is 2. And what is my first term? 1/3 is my first term. Do you guys at all remember what my explicit definition for a geometric sequence was? A sub 1 times r to the n minus 1. Well, we have 1/3 times 2 to the n minus 1. Which one does that match up with for us? Option number 1. We just want to take the summation of it, so we want to add all these together to find out how much total mileage we ran, starting with n being 1 and going up through 7. But again, folks, seeing that this is multiple choice, what's the better way to attack it? Just that trial and error way that we looked at. Just the trial and error method. Okay. There's a lot less room for mistake with trial and error. Okay. But that's also very important to know for the Regents exam as well. Okay. What was the definition of an arithmetic sequence? A sub 1 plus n minus 1 times of the common difference. That was the arithmetic sequence versus the geometric sequence. Okay. All right, on 20? So we're not getting a lot that are straightforward calculator, but we are getting a lot where if we know just bare minimum, skin and bones, algebra 2 and trig, can we work our way through them? Yes. All right. We haven't talked about this. We're going to discuss this next week. Okay. But what we've got here are trig identities, folks. They're telling me that sine x and sine y are both equal to this value a. And that cosine x and cosine y are both equal to b. And we need to figure out what the cosine of x minus y is equal to. And again here, folks, this is just another problem where if we know what is on my formula sheet, we're going to be able to get our answer for this. And if you look at our formula sheet, right here is the cosine of one angle A plus another angle B. Well, do we have A plus B? What do we have? I'm sorry, we don't even have a plus, do we? We've got a minus, right? So right down here, cosine of an A minus B. But do we have an A and a B? No. What do we have? An x and a y. So instead of having an A here, we're going to have x's, and instead of b's, we're going to have y's. So we just need to understand that this identity is right here for us. So let me copy that identity over and bring it onto the page that we're working on here. Yep. Let me pull it down to where we are. Shoot. we go. So again, we don't have A minus B, we've got X minus Y. So we're just going to replace all of our A's with X's and all of our B's with Y's. So the cosine of X minus Y, as they've told us here, is equal to what? Cosine X, cosine Y, plus sine X times sine Y. All you did was just replace your A's with what? X, and your B's with Y's. Okay. And now, did they tell me everything I need to know? Did they tell me what cosine X was equal to? They said cosine X was equal to what? Which was equal to what? B. Cosine X and cosine Y were both equal to B. Plus, what did they tell me about sine X and sine Y? They were both equal to what? Okay. Times A. Well, what is B times B? B squared plus A squared. We're looking at choice. Choice number 2. Have we even talked about trig identities yet, folks? No. We haven't discussed them at all yet. But just knowing that it was on the reference table, were you able to solve it? Absolutely. Okay, and there's a bunch of identities that are on the Regents reference table. Along with subtraction, we've got addition. Over here, we've got double angles and half angles. Okay. So we've got 4 sets of trig identities that are right here for us. Okay. We recognize, well, we didn't have A minus B, we had X minus Y, but is it the same thing? Yeah, we could have X minus Y, we could have alpha minus rho, we could have theta and beta. It doesn't matter what the variables are here. It's just the setup. We had an X and a Y, so we replaced our A's with X's and our B's with Y's. Okay, and we can substitute in and still solve that out. Okay, so just knowing that it was on the reference sheet, we got it correct again. Okay. Questions on that one? And we'll discuss those more next week. We just recently did this one. School math team consists of 3 juniors, 5 seniors. How many different groups can be formed that consist of 1 junior and 2 seniors? Now, folks, all we're forming are groups. Is there a hierarchy involved in forming a group? No. Order does or does not matter? Does not matter. These are permutations or combinations. These are combinations. The order does not matter. Order does not matter. Okay, how many juniors do we have? 3 juniors. We want to select how many of them? 1. We have how many seniors? 5 seniors. We want to select how many of them? 2. Go ahead in your calculator. Tell me, please, what is 3 combination 1? Three. And tell me, please, what is 5 combination 2? What'd you get? 5 combination 2 is not 1. 10. Okay, so as you look, I have a choice that's 13 and I have a choice of 30. Do I add them or do I multiply them? We have to multiply them. That's counting principle. Okay. This is the number of ways you can choose your lunch. You've got 3 drinks that you can choose from, 4 entrees, and 2 desserts. Well, I've got to multiply the 3 drinks times the 4 entrees times the 2 desserts to get the total number of ways that I can get a combination here. Well, that means I've got to multiply these together. There's this many ways to count the juniors, this many ways to count the seniors. I've got to take the product of the 2 of them. There's 30 different groups that would consist of what we want here, 1 junior and 2 seniors. We've always got to multiply those together. All right with that one? 23, another quadratic one, but it's not a full quadratic, notice. We only know which 2 values here. A and the B. We know that the A value is what? 2, and the B value is what? -5. And I want the roots to be real and rational. This only involves what part of the quadratic equation? Only the discriminant. And what is the discriminant? This is only involving b squared minus 4ac. And folks, if my roots are going to be real, then my discriminant must be positive. It's got to be greater than 0. And if my roots are going to be rational, it's got to be what kind of a positive number? A perfect square. It's got to be a positive perfect square. Okay. So folks, what is my b value? And what is b squared? 25. -5 times -5 is 25. What's 4 times my a value of 2? 8c. And so they're just wanting to know which one of these 4 numbers, when I plug it in here, is going to give me a positive perfect square. Well, what's the easiest of those 4 numbers to plug in? 0 is, right? What's 8 times nothing? Nothing. And what's 25 minus nothing? And is 25 a positive perfect square? It absolutely is. Absolutely is. Folks, if I plug in 4, what's 8 times 4? And 25 minus 32 is going to be negative. That would give me imaginary roots. What's 1? What's 25 minus 8? 17, right? And 17 is going to give me real roots, but they're going to be irrational. -5, well, -8 and -5 is 40. Well, what's 25 plus 40? 65 is, again, not a what? It's not a perfect square, so it's not going to be rational. Okay? So the discriminant is always a question on the Regents as well. Always going to be some question involving the discriminant, the b squared minus 4ac. The most important part of the quadratic, because it is the part that is under the radical. Which means if it's negative, we're going to get imaginary. If it's positive, we're going to get real. If it's a perfect square, it will completely come out and there will no longer be a radical. If it's not a perfect square, we're still going to have a radical, an irrational number. Okay? And when are the roots equal? If this equals 0, we have equal roots. Equals 0, equal roots. Okay. Boom, 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 boom. Cliff diver on the Caribbean island jumps from a height of 105 feet with an initial upward velocity of 5 feet per second. An equation that models the height, h of t, so h of t represents the height above water in feet, of the diver in time elapsed t in seconds. So given a number of seconds, I can find out what the height of the diver is above the water. How many seconds to the nearest hundredth does it take a diver to fall 45 feet below his starting point? Well, what was the height at his starting point? 105 feet. Well, what's 45 feet below that? 60, right? They want this right here to be equal to what? They want that to be equal to 60. -16t squared plus 5t plus 105. They want that to be equal to 60. Well, now that we've got the equation, can I just plug in the numbers and find out which one's going to roughly work for me? Yes. Now, will I ever get one of those to actually work to be exactly 60? No, because we had to do what? We had to round it. We had to round it. So none of these are, I can't do the equals test on any of these. I'm just going to have to type that into my calculator with these values stored as t and find out which one is the closest to what? Which one is the closest to 60? Okay, I want you guys to do that, please, then. Okay, start storing these values for t and type it into here and find out which one's the closest to 60. And as you guys are doing that, I'm going to actually solve this quadratic equation by hand. I'm going to move everything over to the other side because I want this to be positive. So this comes over as a positive 16t squared. And please stop me when you found out the one that makes it. Which one is it? Choice number 2 is what it is. Okay, so now follow along with me then. I've moved this over to the right so it becomes positive. What about this positive 5t? It's going to become negative 5t. And from that 60, I'm going to have to subtract 105. What's 60 minus 105? Minus 45 equals 0. Folks, do I want to try to solve this one by factoring? No. Not even going to attempt to try to factor this one. It's even going to be a nasty one for completing the square because of that right there and that right there. How am I going to solve this quadratic? Okay, so not x, but t equals, tell me what the quadratic formula is, please. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Well, what is my a value? A value goes here and here. What is my b value? B value goes here and here. What is the c value? C value goes here. Okay, so negative negative is a positive 5. What's 2 times 16? 32. I just need you to evaluate the discriminant for me, please. Don't type in the square root, just what's inside of the square root. So the parentheses, negative 5 squared minus 4 times 16 times negative 45. Evaluate the discriminant for me, please. 2,905, 2905. Okay, so now into your calculator, please. 5 plus radical 2905. Evaluate that. Divide it by 32. What is it? 1.84 to the nearest hundredth. 1.84. Okay. So after 1.84 seconds, he's 45 feet below where he started. 45 feet below where he started. Okay. Folks, we could have also even solved this graphically. We could have typed this equation into our quadrat or into our y equals, and we would have found something that looked like this. And then we would have had to cross over at the 60, find the time that it happens at. Multiple ways for us to solve this one. Okay, by hand. This is a last resort for multiple choice. It's by hand. We want to try and attack multiple choice the quickest way we can. Okay, so the other methods would be quicker and easier, but anyway, it would have solved this. Okay. We just recently saw this one, arrangements. Does order matter with an arrangement? Yes, this is not a combination, this is a permutation. But notice, we've got letters that repeat. What is that formula for us? N factorial over R factorial. How many letters does trigonometry have? 12, so 12 factorial. What letters are being repeated? t's. And how many t's do we have? 2. So a 2 factorial for the t's. What else is being repeated? r's. How many r's do we have? A 2 factorial for the r's. What else is being repeated? o's. We have how many o's? A 2 factorial for the o's. Anything else being repeated? No, nothing else. Okay. So when you type this into the calculator, though, what do you have to be very, 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 very careful of here? Parentheses. There's only one place where I need them. Where is that one place that I need them? Around the denominator. So 12 factorial divided by parentheses. 2 factorial, 2 factorial, 2 factorial. And tell me what you get when you run that through, please. $59,000,200. Well, notice that's not one of my choices, though, right? They just want to know which one it's equivalent to. Bless you. Okay. Could it be possibly choice 1? No, why not? They're just saying, well, there's 3 different letters that are being repeated, but it's not including which ones are being included. Choice number 2? No, it can't be choice number 2 either, because they were saying there's just one letter that's repeated 6 times. No. Up here, one letter is being repeated 3 times. No, that's not what we've got. Okay? Well, 12 permutation 12 permutation 12 is the same thing as what? 12 factorial. This is the same as 12 factorial. Anything permutation itself is the same as that number factorial. Okay? So really, this one is exactly the same as that one, isn't it? So where are they getting the 8 from as opposed to 2 factorial times 2 factorial times 2 factorial? Yeah, 2 factorial is just 2, right? 2 times 1 is 2. So this is 2, this is 2, this is 2. 2 times 2 times 2 is 8. Choice number 3. Choice number 3. All right, 25. A little bit of a twist they've thrown onto it. Log, we've seen a couple log problems throughout here, but we've got 2x to the third equals y. Then they want to know what log y is equal to. Well, again, folks, if y is equal to 2x to the third, if those 2 expressions are equivalent, then as long as I do the same thing to both sides, are the expressions still going to be equivalent? So folks, if I've added a log in front of the y, then what do I need to add in front of the 2x to the third? I need to take the common log of that as well, right? Well, now over here, we've got multiplication going on, right? What does multiplication expand into with logs? Addition. This is going to be the log of one of those parts plus the log of the other factor. So log what plus log what? Log 2 plus log x cubed. And then what are we allowed to do with this exponent with logs? Move it to the front of the log. So we've got the common log of 2 plus 3 common logs of x. We're looking at choice number 4. We're looking at choice number 4. Folks, can I do this one on the calculator knowing absolutely nothing? I absolutely can. But notice up here, am I just randomly storing a value for x and y? No. Bless you. Y depends on what other value? Yes, so y depends on x. So let's make an easy number for x. Let's let x be 5. So then in your calculator, type 2 parentheses 5 cubed. What's 2 times 5 cubed? Store that as y. What was it again? 250? So I randomly picked the x, but then I typed in this expression to get the y. Okay? And now they want to know what log y is equal to. So in your calculator, type log y. Tell me what you get for log y. 2.397 ... right? Okay. Start typing these ones in. Tell me which one's going to be the exact same. Now, obviously, for time's sake, let's go right to 4. Type in number 4. What do you automatically get when you type in log, though? So make sure you close it. Log 2 plus 3 log x. And I bet you get 2.397. Correct? Yes, and that's the only one that's going to give you that. So is this really kind of a know-nothing calculator one as well? Absolutely. So I just store a value for x. I calculate that expression and store it as y. Now I can just run it through my calculator again. Log, definitely going to see some form or another of log on the Regents exam. That's a big topic. Last multiple choice question we've got here then. Which statement regarding the inverse function is true? And we really haven't talked about trig graphs enough to be able to do this one. But folks, how do I get this on my calculator? How do I get this sine negative 1x or cosine negative 1x? Second, right? So could I go into my calculator and go to y equals and type in second sine x? Could I do that? And then go to zoom 6. Very importantly here, though, what mode should I be in here? Why radian here? There's no indication of degrees at all, right? I need to be in radian mode. Okay, so I'm in radian mode. Y equals inverse sine x. I'm going to graph it. I'm going to zoom 6 it. Anyway, zoom 6. And is zoom 6 a little bit much? Yeah, it's a little bit too much. So if you go to zoom, we can zoom in. I'm going to hit option number 2. I'm going to zoom in. And notice it gives me the coordinate 0, 0. Yeah, that's where I want to zoom into. I want to zoom into the origin, so I'm going to hit enter. Is that a little bit better? Yes. And they're asking me which statement is true. So the domain of sine, the range of sine. Okay? So let's look at this. Let's hit trace. Domain. Well, it looks like my x values, notice I'm not getting a y value right there, right? I need to come back into right about there. So my x values start roughly where? -1. And they go through to roughly, and there I'm not getting a y value, so I got to come back one. They go roughly to where? 1. So the domain goes from -1 to +1. Does the main go from 0 to 2 pi? No. Does the range go from -1 to +1? No. Look at the range right here. The y value is up at 1.27. So is it either one of these two? No. So let's type in inverse cosine. Y equals second cosine. And I'm going to go to that same graph. And now let's talk about this one. Does its domain go from -infinity to +infinity? No, that means that every single x value here, the graph would go along that. No, it doesn't. But does the range start down here at 0 and go up to 1, 2, maybe pi? Yeah, that's the one we're looking at. That's the one we're looking at. So we don't know anything about trig graphs yet, let alone anything about inverse trig graphs. But can I type every single one of those into the calculator and look at their graphs? Yep. So if I know what domain and range mean, I can answer this question without knowing it, right? Okay. How many questions in this part have we looked at tonight where we haven't known what to do yet? But either using the reference tables or our calculator, we were able to answer them. There was at least like 3 of them, right? Okay. So just having an understanding of using the calculator, of just using our reference tables, we can get by on this exam. We can get by on this exam. We just got to know what's where and how to use our calculator. Okay? Questions on that? Okay, I got 8:30 then. That's a good spot to end at. Now, I know we haven't done all of these individually, but we kind of went through and looked at the ones that we hadn't seen yet. So unless you guys have a very specific question that, yes, I do want to look at on one of these Part 2s, 3s, or 4s, then I'm going to go right into the next Regents exam for Thursday. Okay, unless you've got a very specific question that you do want to see. Ooh, I do. Yeah, we are going to come back and look at that one. We're going to come back and look at that one. Okay? Questions at all, folks? Okay, thanks for coming. Have a great evening, and we will see you Thursday. I will not see you tomorrow because I'll be grading that exam, so we will see you on Thursday. Okay?